1.3. If I had the quadratic equation x squared minus x minus 56 is equal to 0, and I was told solve, instead of just factoring, I want to find the values of x that make this true. So hopefully you can factor this without the box now. If the box helps, feel free to use it. But I know it's going to be x and x. Can you think of two numbers that multiply to be negative 56 and add to be negative 1? 7 and negative 8. So positive 7 and negative 8. And these two multiplied together still equal 0. Okay. Let's look at this in a different light. If I had a times b is equal to 0, the only way to multiply two numbers together and get a 0 is either a equals 0 or b equals 0 or both. So we know if that's a and that's b, then either x plus 7 is equal to 0 or x minus 8 is equal to 0. Does everybody understand that? Okay. Well, how do we solve this? Just subtract 7. And I get x equals negative 7. And on the other one, I add 8. And technically, we should say x equals negative 7 or x equals 8. But we're super lazy. At least I am. So really, we just do this. X is equal to negative 7 and 8. What is the significance of those numbers? What does negative 7 and 8 tell us about this equation? That's where the graph hits the x-axis. So if I were to graph that original quadratic, it's in the shape of a parabola, and it hits the x-axis at negative 7 and at positive 8. Good. The other thing it means is if I plug this number in here, I will get 0. And let's try it. 8 times 8 is 64. Minus 8 minus 56 is equal to 0. And the same thing happens with negative 7. Negative 7 times negative 7 is 49. And then negative 7 is plus 7. Minus 56, that is 0. And it turns out those are the only two values that hit 0. So graphically, they are x-intercepts. We call them roots. And algebraically, those are the only two numbers that create a 0 when you plug them into the equation. Okay, does that make sense? Let's do another one. Let's do and then I need, sometimes it will say equals 0, or sometimes it will say equals y, or sometimes it will say equals f of x. And those all mean the same thing. As long as it says solve, you want to know where does the parabola hit the x-axis. Okay. Can you think of two numbers that multiply to be negative 6 and add to be negative 5? So negative 6 and 1, why not this? Or do they both work? What's wrong with negative 2 and negative 3? They do not multiply to make negative 6. Good. Okay. Well, that is equal to 0. So I set both factors equal to 0. and I add 6, and I subtract 1, and the factors are 6 and -1. Okay, does anybody want to see another one? We're good? Okay. What if I told you I'm thinking of a parabola, of a quadratic equation, and this quadratic equation hits the graph at 2 and at 4. What is the equation? Well, I need to take my roots and turn them into factors. So if the roots are 2 and 4, what would the factors be? X minus 2 and x plus 4. Now what should I do? Oh, because I don't know what I'm doing. Thank you. Now what? So equals 0. Yeah, now I need to multiply them together. So you can do it this way, or you can set it up in the box. So x squared, -2x, -4x, -4 times -2 is 8. And then I get x squared minus 6x plus 8. Do you guys understand that? Okay, let's do another one. What if I had x equals 7 and -5? How do I turn those two roots into a quadratic? One factor is x minus 7. And the other one is x plus 5. And I'll multiply this the other way. X squared plus 5x minus 7x minus 35. X squared minus 2x minus 35. Now, something interesting to note. This is one possible correct solution. It turns out there are an infinite number of correct solutions. Now that does not mean every equation is correct, but all we need to satisfy is this requirement. So how many parabolas are there that hit at -5 and +7? Lots. I just created that one. But if I were to times this entire equation by 2, then I would create a parabola that is twice as tall, but it still hits the same place. If I were to take this equation and divide everything by 5, then I would create a parabola that still has the same roots, but it's going to be 5 times as short. I missed, but you guys get the idea. Right there. So there are an infinite number of correct answers, and it turns out this one happens to be the easiest one to find. That's the one that's created just using the roots and not doing any multiplying or dividing. Okay? You guys think you can handle this? There are only 2 types of problems in this assignment. Find the roots and then create a quadratic given the roots. All right, go for it.